Good morning and welcome to our webinar on a testing strategy for AWS Cloud Native Applications. My name is Josh and I will be your host today. You know your business can benefit from the cloud native technology, but what does this mean for your testing strategy? In this webinar, we will share a testing strategy, approach, and methodology we've developed and implemented at many organizations using AWS Cloud Native Stack and the Infostretch factory model. We'll also explain how you can build your cloud native stack highly secure and completely error-free. Today's presenters are Anjali Sivakumar from AWS and Sivakumar from Infostretch. Anjali is a partner solutions architect at Amazon Web Services. In her role, she advises customers and partners on how to architect reliable and scalable solutions in the cloud. Anjali has a master's in computer engineering from the University of Texas in Dallas. Siva has more than 20 years of experience developing and managing QA strategies for Fortune 500 companies. In the 9 years with Infostretch, Mr. Anna has been instrumental in leading strategic enterprise engagements, which have resulted in significant value for clients such as Kaiser Permanente, The Body Shop, and Minted.com. Before we begin, let me review some housekeeping items. First, this webcast is being recorded and will be distributed via email to you, allowing you to share it with your internal teams or watch it again later. Second, your line is currently muted. And third, please feel free to submit any questions during the call by utilizing the chat function on the bottom of your screen. We will try to answer as many questions towards the end of the presentation that we have time. If we do not get to your question, we will reply to it via email to make sure we get you the adequate answer. We will do our best to keep this webinar to the 45-minute time allotment. At this time, I'd like to turn the presentation over to Siva.
Thanks a lot, Josh, for the introduction, and thanks, Anjali, for being part of this session with me. Hello, everyone. Let's just get started. So today's session will start with highlighting the key aspects of the cloud native applications, right? We'll kind of do a quick overview because that's going to be the baseline for our discussions today. So we'll kind of cover many of the cloud native components. So that's what I would like to kind of start with. You can also see that the cloud native components cover the entire spectrum of application in terms of the architecture and the different solutions. For many of the cloud native components does come from AWS offerings also. So you will see the reference of how does the AWS components or the solution fits into the overall cloud native application solution, right? Then we will kind of deep dive into the testing requirements. That's the core of this particular presentation. So we'll talk about the approaches and the specific area that you need to be focused based on your application design. Again, the testing strategy that we kind of shared today would be generic one, but that needs to be customized based on your specific applications in terms of the design and the requirements that you might have for your needs, right? Towards the end, we will kind of walk through a case study. So what we kind of discussed today, you will see how we kind of successfully implemented and what's the kind of outcome that we have achieved in the particular case study that we'll be walking towards the end of the session, right? So you will see that how we use both functional and non-functional aspects to ensure that we are able to build a robust application and how that testing has been implemented successfully. You will see that as part of the case study. Right. So moving on to the next slide. So just to kind of, like I said, to give the specific, the cloud native definition, right? So this is what is being outlined in the cloud native community forum. It's a very simple statement. It's basically empowering organizations to build and run scalable applications. This has become as a mantra for all the enterprises that are kind of start migrating to the cloud platform, right? So just to give some background, the CNCF was founded in 2015 with the mission that to For many of the technology leaders became part of the CNCF Foundation and have been contributing to the successful implementation of many of the solutions that are available as the blueprint from the CNCF Foundation, right? AWS joined the CNCF community in 2017. It's been 2 years. They have been kind of continuously participating and providing solutions to make the adoption as well as to make the CNCF the forum a successful one. Right. We kind of a little bit took that definition and added few more keywords because based on our experience working with many of the customers, we have seen few more attributes also becomes as a need. So we've added a couple of keywords. It's basically how you kind of build a robust application, but that requires a very strong testing approach as well, right? So that's what you will see in the subsequent slides. It's basically what we have seen. This additional statement does align to the business needs that we have seen with many of the customers. They look out for a secured way of testing the application as well as make sure that they are able to distribute the application to meet the demands from the customer base, right? Moving along, just to kind of one more slide before we go deep dive into the actual the testing approach, right? So like I mentioned before, AWS became a critical partner for the cloud native community and providing solutions in the past, right? To give an example, the EKS CTL was announced recently. It is one of the Elastic Container Service for Kubernetes. That was something announced, I think, a couple of months before. It is one of the solutions that was jointly developed by AWS and vWorks, right? So that you will see in AWS portal, and there is a lot of solutions like this has made adoption of the cloud platform much more easier. Infostretch has been working on many AWS cloud implementations. We work with many of the customers to kind of provide the solutions. With this experience, we have designed, developed, and implemented many of the testing approach. So that's what I'm going to talk about, how we have used and how we have kind of successfully tuned our testing approach, that you will see the real benefit of these solutions in your implementation, right? So let's get to the actual next slide where I talk about the different components, the cloud native components, and how the testing kind of fits into the landscape here, right? So as you can see in this slide, these are all the various components you can leverage to design and develop the cloud native applications, right? So your application may or may not have all the components that are listed here, but these are all the different components that you will end up choosing to kind of build your applications, right? And keep in mind, this is the set of components keep evolving. This is kind of going through a continuous change because there is so much improvement that is happening day by day. So there is I think you need to be kind of keep watching what all the components available, what solutions available. For example, the set of solutions that are available, for just to take an example of databases, there are like 20 or 25 solutions available, right? So you need to kind of constantly watch out what is available, what would meet your needs or business requirements, and you can kind of select those components for your to kind of meet the your application design, right? So just to give one, so these components are kind of stacked horizontally, like you can see those components. For example, app definition and development is one set of components, that the first layer, and the orchestration and the management is the second layer. So you will see these components are kind of horizontally stacked against the different the activities that you will end up doing as part of your the development life cycle, right? So in the next slide, what we have done is to kind of transform that into the various the cloud native components stack, how we kind of put it into 5 vertical tracks. These are all the tracks that you will end up seeing in your application for your needs, right? So our testing approach is kind of more tied towards these 5 vertical tracks. So there is going to be that I'll be kind of covering, right? So to put these components, they are like divided into 5 tracks. I think to give an example, for any application development, you will start with some of the design principles, or to give an example here, the 12-factor apps. So you want to make sure that the application that is being designed and developed for a cloud-native platform, you want to make sure that that is adhering to this 12-factor app policies or the guidelines, right? So to give a simple example, for 12, one of the principles is the stateless processes. So the processes that you build for your cloud native platform to be stateless, right? So the guideline is basically saying that that should be stateless, that should not share information between the processes. So that's one of the guidelines. So the testing approach that you will see in the subsequent slide does talk about how to validate, how to ensure that these policies are kind of enforced correctly, and how does the microservice architecture that is being kind of tested, whether it is how the contract testing is happening, how the data privacy is being kind of validated. So that's what you will see, and that is what is the core, I would say, kind of a big differentiating factor between an application like a monolithic application that goes through the migration to your cloud native applications, right? So that's what is a big delta that you will see and that we have touched upon in the next few slides. So moving on to this one. So this is, I think, the first slide I talked about. So what we have seen, the previous 5 tracks that you saw, the 12-factor apps, microservices, DevOps, and everything as a service, then the distributed deployment that you will have for your cloud native applications. We kind of divided this into 2 categories, what we call it as the pre-deployment phases, that basically has this 12-factor app verification and the microservice architecture verification. We kind of bundle them as part of the pre-deployment, right? So that basically includes all activities that you will do before the deployment phase, designing, development, review, all these activities that you'll end up doing before the application deployment, right? So these are all the things that we kind of call it as a pre-deployment, and we kind of in our experience kind of going through multiple implementation as well as kind of verifying these implementations, we kind of defined 2 models. One, what you see here is the static security factory model. So what we kind of do here is basically to do the static security services. That basically, as you can see here, the list of activities that we do, whether it's a vulnerability or the compliance code vulnerabilities, or making sure that any patch upgrade happens for various components that you will use as part of the cloud native applications. Those are all the things that you want to make sure that gets tested successfully as part of this phase. Again, this all would be part of, most of the times that we have seen, many of these activities becomes part of the CI/CD cycle. So it's not that you have to explicitly perform, but it is important that you follow this the model to ensure that we are able to validate this aspect, right? So the factory model, primarily the static factory model, is primarily used to perform the footprinting of the network or the network or the application or the code vulnerabilities such as the SQL injection. And same goes for even application certificates are effective, or if there is any expired certificate, you want to kind of bring it to notice. So all that would be part of the static security testing, right? So this definitely takes place as part of the pre-deployment phase. So it runs against the code that is being deployed. So most of the time, there are tools and solutions that are available to run against, let's say, GitHub, right? So it will be kind of just scanning through the code and perform these activities to ensure that these things are being done automatically. So the next part of it, what we call it as either the post-deployment or what we call it as the dynamic security. So this is where the application functionality is tested more from the end user perspective, right? You should make sure that both the functional aspect as well as the non-functional aspects are being getting tested successfully here. So the things that we cover as part of this one is, like I said, functional and non-functional is one run, but we also do the acceptance tests coming from the business use cases. So all that becomes as part of the dynamic, right? So some of the things that we do here, basically, any changes that happens in the code, we want to verify as part of the deployment. The deployment especially may be in a multiple locations, to make sure that the distributed deployment is successfully validated. So the idea of the dynamic security and testing model is to classify the entire production chain into in terms of the visibility from the end user perspective, are they working correctly or not, right? So that's the primary objective of the dynamic security, right? So to data privacy and the session management is another key aspect that we usually cover as part of the dynamic testing. What I mean here is, I think I can cite one of our customer scenario that we did see there was a data a privacy issue. So we saw that in a specific load conditions, their data gets kind of goes from one session to another session. So we have kind of identified, and in that particular instance, we did combine both the functional testing with the load testing to kind of verify that when a specific load is being kind of generated, how does the system functionalities work, especially the data privacy or the caching, cache refresh or race conditions, all that gets tested, which may or may not be there in your monolithic applications, right? So that's one of the key things that we have seen, and we have kind of enhanced our testing model or the framework to incorporate these things. So this is the combined view of both the static and the dynamic security models, right? So you'll see the pre and post deployment phases for any typical cloud native application lifecycle, right? So just to summarize, the static security model is designed to pick appropriate tool from third-party tool set, right? So like I said, there are like a bunch of tools available. AWS does provide quite a few components or solutions for any cloud native application design. So I think we strongly recommend to kind of look at the AWS tool set to see, so that you'll be able to leverage these solutions for your application, right? And this is primarily to identify the scope and the tools involved, and also find out, are there any gaps that tool may or may not be supporting today. It might be in the roadmap. Identify the gaps and see, do you want to extend the tool? So that's another activity that you will do. And also identify the vulnerabilities that are reported as part of the tool reports, and see how to mitigate those gaps. What are the solutions that are available there to address those gaps? You need to kind of put this in your approach, right? I think one of the key things that we also have seen, especially for the dynamic security model, we have built kind of an automation framework that validates both the functional as well as non-functional aspects. What we call it as the cyber secured automation, QMetry automation framework that supports many of the testing that I talked about here, like the caching conditions or the session management or the data privacy all that, we have a mechanism to kind of generate those specific conditions and validate that through the automated fashion, right? So the QMetry automation framework is supporting these testing needs that we see in a typical cloud native applications, right? So moving along. So this is kind of a simplified view for your typical testing lifecycle that you will see in any application, right? So what you will see from pure SDLC perspective, right? So this basically covers the set of testing activities that you will perform at any given stage of your application development. Again, you will see that this highlights what kind of functional testing you will do at which stage of your application, what kind of non-functional testing that you will do. All that is being covered as in this simplified diagram. Right. So with the help of static, the security factor model that we have and both the dynamic security, it is possible for delivery team to identify resources, right? So in terms of what skill set that you need, what kind of training that you may need to do for your team members to kind of achieve the right level of testing, right? And also as part of this one, you will see that what kind of the risk and proposes the mitigation plan as part of this one. Like I said, the automation framework that we use for this kind of an engagement does come with a lot of pre-built accelerators. We use it for like I said, there could be a situation that a specific condition, it could be a race condition or it could be a cache refresh happening on a specific load condition or time condition, right? So we have accelerators to kind of mimic the load and also kind of making sure that, okay, the component is being running for certain timeline. So we have a mechanism to kind of inject those specific conditions so that we can mimic those production situations. So that's what we kind of cover as part of our framework, right? So I think I will hand it over to my partner in this session, Anjali. She will kind of cover a few slides to talk about what does AWS offer in this particular space. Anjali?
Yeah.
Thank
you guys
you.
can hear me okay?
Yes, Anjali, I can hear you. Yes.
Okay. Thank you, Shiva. That was a lot of great information. Hi, everybody. This is Anjali, Partner Solutions Architect at AWS. I will talk to each of the bullet points mentioned on this slide here. And I'll touch upon some core AWS services that fit well here with the Infostretch's cloud native stack. To give you an idea of the breadth of the AWS platform, specifically with programming support, we have a lot of service offerings that automatically deploy and manage applications and systems. We have a rich set of capabilities. For application-centric development, we support Java, Node, Python, Ruby, PHP, .NET, and Docker workloads on AWS Elastic Beanstalk and Amazon EC2 Container Service. Talking about elasticity in the cloud, before customers used to over provision to ensure they had enough capacity to handle their business operations at the peak level of activity. But now they can provision the amount of resources that they actually need, knowing that they can instantly scale up or scale down along with the needs of their business. This also reduces cost and improves the customer's ability to meet users' demands. Next, talking about user authentication, notifications, and queuing systems, we have a service called Amazon Cognito, which lets you add user sign up, sign in, and access control to your web and mobile apps. For notifications, we have a service called Amazon Simple Notification Service. It's a highly available, durable, secure, fully managed pub-sub messaging service. And we have a service called Amazon Simple Queue Service, QS, which is also a fully managed service. It's a message queuing service. Both Amazon SNS and Amazon SQS enable you to decouple microservices, distributed systems, and serverless applications. Next, touching on storage and networking in AWS, Amazon Simple Storage Service S3 is an object storage service that offers industry leading scalability, security, and performance. And there's Amazon S3 Glacier for archival. For networking, there's Amazon Virtual Private Cloud, VPC, using which you can provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. Next, we also have a complete set of tools to automate code builds. We have cloud formation, code pipeline. For deployment, there's code deploy. And for API management, there's Amazon API Gateway. Josh, if we can go to the next slide. Thank you. So in this slide, we'll talk about how we can apply the 12-factor app methodology to serverless applications. So with reference to the 12-factor app methodology, if we quickly go through these best practices here, for code base, for a single serverless application, your code should be stored in a single repository in which a single deployable artifact is generated and from which it is deployed. This single code base should also represent the code used in all of your application environments like development, staging, production, etc. For dependencies, code that needs to be used by multiple functions should be packaged into its own library and included inside of your Lambda deployment package. For config, both Lambda and Amazon API Gateway allow you to set configuration information using the environment in which each service runs. For backing services, because Lambda doesn't allow you to run another service as part of your function execution, this factor is basically the default model for Lambda. Typically, you reference any database or data store as an external resource via an HTTP endpoint or DNS name, and these connection strings are ideally passed in via the configuration information. For build, release, run, there's AWS code deploy, code commit, and code pipeline that can be utilized for this factor. For port binding, this factor also does not apply to Lambda, as execution environments do not expose any direct networking to your functions. Instead of a port, Lambda functions are invoked via one or more triggering services or AWS APIs for Lambda. For concurrency, Lambda was built with massive concurrency and scale in mind. Lambda automatically scales to meet demands of invocations that you send to your functions. For disposability, shutdown doesn't apply to Lambda because Lambda is intrinsically event-driven, so invocations are tied directly to incoming events or triggers. For dev prod parity, products within the AWS serverless platform do not charge for idle time, which greatly reduces the cost of running multiple environments. And you can also use the AWS Serverless Application Model or AWS SAM to manage the configuration of your separate environments. And AWS SAM allows you to model your serverless applications in greatly simplified AWS CloudFormation syntax. With SAM, you can use CloudFormation's capabilities such as parameters and mappings to build dynamic CloudFormation templates. And for logs, API Gateway provides two different methods for getting log information. There's execution logs and access logs, and both are also made available to you in CloudWatch logs.
Okay, thanks a lot, Anjali. So thanks for the detailed walkthrough of the AWS offerings on this cloud native application stack. So continuing on the same, like we talked about the previous two slides that Anjali talked about the AWS offering. So continue on the same thing. So what you will see here a set of components that are available for the various tracks, right? So you will see the different solutions that are available for for each of the tracks, right from the application database technologies. Then you will see that for the CI technologies, what is being available from the AWS perspective. You will also see the infrastructure and the deployment aspect, right? So this is basically a little bit loaded slide. You will see a lot of solutions, and I just want to kind of highlight, if not all, some of the solutions that are out from the AWS. I think Anjali did touch upon some of the log components and the database components. We continue to see that more and more components kind of filling up from the AWS space on these different activities. Right. So we basically kind of the static and the dynamic model that you saw in the testing model that you saw in the previous slide does support all these components, right? So irrespective of what components that you choose for your application development, the framework does support kind of coming out with a testing approach for those components, right? Again, I want to kind of highlight or repeat that this space is kind of getting filled up with components day by day. So you will see new components popping up, more and more components coming from AWS also to support this cloud native the stack, right? So just continuing on, I think I have a couple of slides to talk about the approach that we have for both the static security as well as the dynamic security model, right? So in this particular next two slides are about these two models. So in the case of static model, we perform basically a set of activities, right, from validating the readiness of the infrastructure all the way setting it up, then activating the controls or the quality gates, monitor those controls or kind of enforce during the life cycle of the application, right? So that's what we kind of do as part of the static security model definition. So this is the kind of set of activities that we go through. We identify what are the things that is available today and what we need to kind of adopt from the, say, for example, from the AWS platform. And we kind of putting the necessary controls, like, for example, the 12-factor apps, what controls that you want to have. Again, depending on your application design requirements, you kind of pick and choose what the kind of testing approach that you want to have. So all that will happen as part of this, the approach that we kind of define here, right? So you'll definitely see an output coming here in terms of certain artifacts that would be kind of as a reference document would continue to maintain going forward also, because that would be a living document to ensure that anytime there is a policy enhanced, that document would be updated, and that would be used against both the monitoring as well as controlling aspects, right? And on the dynamic part of it, pretty much the same set of activities that go through, but it's little variation more from what we kind of do the dynamic in terms of what kind of testing that you do, what kind of infrastructure monitoring that we do as part of these systems, right? And I think especially for the dynamic part, there is a lot of log analysis happens, because the data, whether it is application execution logs or whether it's the test execution logs, we want to kind of use the tools, set of tools that are available to automatically validate anything that can be inferred from those logs, right? In this particular approach, one of the output that we produce as part of every engagement is some kind of a risk indicator. It's a low, medium, high risk indicator that we produce to kind of constantly evaluate the state of the application, more focused on the security aspect. Okay. And just to kind of give you a flavor of that, the different testing that we do for a typical cloud native applications, right? So we kind of look at from 4 angles in terms of whether it is a business facing or whether it's a product, the criticality, or the customer facing. Like for example, I talked about the auto scaling and data swap validation, right? This is something that we do see for many of the enterprises when they move from monolithic to cloud applications. We tend to see these problems not being taken care during the design phase. So this is something that we do as part of our cloud native application testing specific, right? So especially then the second part is about the contract testing. We do see that there is a big adoption of the microservices architecture as part of the cloud native applications. So we do see that the contract testing is one of the key things, and we have mechanism, and our automation framework does support this contract testing, right? So one of the last slide before I kind of complete my session, then we can go into Q&A session. This is about the case study that I talked about that in the beginning. So this is the case study for one of our current customer engagement. This customer is in the healthcare industry. They are basically a platform provider. They provide a platform for the pharmacy benefit management. And they basically, this particular implementation or the customer environment requires to process high volume of data transactions, right? So they being in the healthcare industry and acting as a platform, there is going to be a high volume of data transactions. So here we basically, the requirement was to kind of how we can reduce. I mean, obviously the cost was one of the key factors for us to kind of while coming up with the solution, and also coming out with a solution that would reduce the maintenance sufficiently to kind of make sure that we are able to easily reduce the maintenance and increase the deployment of the applications in easier ways, right? So what we have seen is that in the final solution that you will see here, I think some of the components, hopefully you can read it here, but to give an example, for example, the database that was used before we did the migration was the SQL Server. So we adopted based on the data growth that was identified. The requirement was that it should support 6 to 8 times in the next 3 months with the volume of data that is being available today, right? So based on that, we did look at it, and I think our engineering team did go with the AWS Aurora database. It's a Postgres database. That's what used for this particular engagement. And also for logging mechanism, I think Anjali also highlighted, we use the AWS CloudWatch for the logging analysis, right? So that's what we have seen, and like I mentioned, we heavily use our framework here. We did use both the static and the dynamic testing. We did put both the static as well as dynamic testing part as part of the CI/CD process, right? So as you can see, there was a huge cost savings that's being highlighted here, both just moving from the local monolithic application to AWS cloud applications, and also adopting some of the other components. There was a huge cost savings that we were able to kind of realize in, I think, close to 9 months engagement that we have done it, right? So this is something that we are currently working, and it's an ongoing engagement, but we were able to kind of see some of the benefits in the 9 months duration, right? So almost I'm done. Just to kind of recap what we have discussed before that, I think we do have a lot of events coming up. I think you can visit our Infostretch website to see some of the upcoming events. You are more than welcome to sign up. We have a DTV channel also, so you will see that a lot of videos also being posted over there. To summarize, right, so what is the cloud native stack that we talked about, and what we bring to the table in terms of the testing framework? The cyber-secure QMetry automation framework is something that we have used, and that's what we recommend for any AWS cloud native application development. that supports both the functional as well as non-functional aspects. Right? Just the last slide before I hand it over to Josh. Right, so I think you will continue to see that in terms of the dynamic and the static security model. And I think it is definitely a journey that we have seen. I think we have been working in this space for last 3 years or so. So we have evolved our framework to support the demands or the needs that we have seen across many of our customers, right? And anyone is looking for any quick assessment or validation, please reach out to Infostretch. We'll be more than happy to have a quick discovery call to kind of share what we have talked about here, what we do as a assessment exercise, and we'll be more than happy to kind of exchange ideas to help you overcome the challenges that you might have, right? So with that, I will hand it over to Josh.
Great, thanks, Siva. At this time, we would like to get your questions answered. As a reminder, you can at any time ask a question utilizing the chat feature at the bottom of your screen. First question is for Siva. Looks like we're getting a couple in. I want to get this one out the door real quick. Do static and dynamic models work in a cloud-agnostic microservice-based setup?
Okay. Yes. Yeah. So the answer is yes. So it is fully support any kind of cloud that you might end up using. We kind of, like I said, AWS is many of our industry. I mean, in our customer implementation, we have used AWS, but we do, our framework does support any other cloud platform also.
Okay, great, thank you. Looks like we're getting a couple more questions. Looks like, so someone's asking, on average, how many vulnerabilities and exploits do you come across for a single app, a single server type setup?
Okay, that's, I mean, it depends on various factors, right? So especially in the beginning of the application lifecycle, we do see many of the vulnerabilities, especially if they are not following the 12-factor app policies and other things. We do see many vulnerabilities in the beginning, but the good thing is the framework and the tools that are available, they do tend to catch very early in the cycle, and we will be able to kind of come out with a fix for those things, right? Especially the version compatibility is one of the things, because we do see components coming out with new versions very often, and there are patches available, patches being released. So you want to make sure that you are up to date in terms of the patches that are, latest patches that are available.
Okay, great. Looks like we have another question coming in. Do you have automated scripts for non-functional maturity model and static security factory models as well?
So let me answer this question. In most of the cases, yes, we do have, like I mentioned, the framework does have scripts available to support both the static as well as the dynamic part of it. There are certain situations that the automated solutions may or may not be applicable, but the answer is yes. I think I would say good 80 to 90% of testing that we do today in our engagement is all 100% automation.
Excellent. All right, and looks like unfortunately we're running short on time. So like I mentioned earlier, if you want to submit your questions, please go ahead and do so. Continue to do so, and we will respond to them via email. And I believe that's all the time we have left for today. Be sure to as Siva mentioned, if you're interested in discovery call with us, please submit your that request via info@infostretch.com. You can also reach us at 408-727-1100. I want to thank both Siva and Anjali from AWS and Siva from Infostretch for taking the time today. It was a really interesting discussion, and we look forward to hearing from you if you have any questions. Otherwise, enjoy the rest of your day. Thank you very much.